Great. So welcome. Like I said, my name is Kristen Sosulski, and I'll be your instructor for the R portion of this course as part of the MSBA program. And right now I see about 10 or 11 of you online, so thank you for joining us. And I just want to do a quick audio check, make sure that everybody can kind of hear and see each other. If you have a camera, it is possible to enable that. So why don't we go to the next slide? And I just want to make sure that you can hear me. And you have a microphone icon. Yours might look a little bit different if you have the web version of GoToTraining. But nonetheless, you'll have something that looks like a microphone icon. Make sure that you are muted. I've taken the time to go ahead and mute you already. I have that control. But what I'm going to do is I'm going to unmute you. So we'll hear a little feedback. So now everybody can kind of speak freely. This tends to create some feedback, so just make sure that you mute yourself until you have an opportunity to ask a question or introduce yourself. So thank you. So I've been talking for a minute or two, and perhaps for some of you, you might not be able to hear me. So I'm just going to highlight this. If you can hear me, please type text yes in the text chat window. And the text chat window you can find below here. Okay, thank you, Jason. Thank you, Anne. Thank you, Chow, Janky, Maria. Okay, I appreciate the feedback. So this text chat is one way that we're going to communicate in this course, in these online sessions. We'll also have opportunity to actually use our voice and talk, since those capabilities are here. Great, thank you. Thank you, Paulo. Okay, so as we go through the class, please, if you at any point, please ask questions, and you can ask them through the text chat. I'll be monitoring it as I'm teaching and as we're having discussions. If I miss your question for any reason, please feel free to repeat it. Won't be offended at all. And if you have something that you want to send privately to me, like, oh no, my audio is not working, or I have to leave early, something like that, that the whole class doesn't really need to know. You can go ahead and simply choose my name in the drop down menu here and just send me kind of a private message. You can also do that with any of your fellow classmates as well. So it's like the equivalent of sending notes in class. So I like to call this kind of like our Twitter feed or back channel for the course, right? So we have this kind of like dialogue that's going on in the chat as we're discussing various topics related to R and coding in R. Also, like for some of you, I think, okay, just one person that's online right now, you have the ability to share your camera if you want to. If you decide to enable your camera, that's quite possible. Just make sure that your lighting is adequate and you're happy with your image and the camera position and whatever you're wearing. Okay, so that's just like a little reminder there. I have my camera on, but I'll turn it off in a few minutes because I find it a little bit distracting, but I just wanted you to put kind of a face with a name. And I like to do the same with you if you have the ability to use your webcam. So that's, again, enabling it. So right now, I've just allowed one person to share their webcam if they've decided to. The rest of you probably are in the web version of GoToTraining, which doesn't allow for the camera sharing. Okay. Also, if you've dialed in, please make sure that you've muted your telephone. And as you come into class, these live online meetings, just please follow this protocol. If you have a question, there's an ability to raise your hand with the little hand raise icon, or you can just simply just type your question in the text chat and I'll respond to you. Great. So yeah, Anne, I see your message. So one of our classmates, Anne, wrote me a message, and so you might not have you might be on the web version, so I don't see a camera icon for you. And it says that you're on the web. So GoToTraining doesn't support camera for the web-based version. If you download the desktop version, you'll be able to share your camera. So here's our agenda for today. So we have a little under an hour and a half now. And what I like to do is first learn a little bit more about you and your background, your prior knowledge with R and R programming. And I want my job as your professor is to make sure that you're learning R at whatever level. I'm specifically looking to make sure everybody's learning at a really basic level. And that a really basic level is, today we're talking about lessons 1 and 2 or chapters 1 and 2 from the R book. I'm going to take some time and just do a quick mini lecture, like maybe 15 minutes, on a basic overview of R, some things that are important just about coding and specific to R. And then I'll provide you with an opportunity to practice in real time. So during my overview, I'll pose some problems and I'll ask you to solve them using R, and then to kind of cut and paste your responses in the text chat. This works really nicely. Last night, I met with 22 other of your classmates from the MSBA program, and it worked really well. And I've been teaching in this format for this particular course since 2014. And so we've tried a lot of different ways, and this way it really works nicely to get everybody talking and learning more about each other and just sharing a little bit about their experience and also how they solve problems, the problems that I pose and how they solve them in R. You'll notice that there are many ways that we can kind of answer a question in R. It's not necessarily always a binary solution. So I hear somebody might have their, so Jason, Jason Moss, I just asked you to mute yourself. Thanks, I'm just getting a little feedback. Okay, thank you. And oh, Jason, you also have a webcam, so I'm gonna allow you to share that if you like. Okay, and then I want to give you an opportunity to answer your questions, of course. So what I like to do is start with getting to know you a little bit better. And what I'm doing is I'm going to be pasting a link in the text chat. So I just need a moment to do that. But I'd like you to simply complete a survey. And I'm just going to cut and paste this link into the text chat. And here I'm just asking you a few questions. What sessions have you reviewed? What exercises have you completed? What's your prior experience with R? And if you have any kind of like urgent questions or just things that you're kind of curious about, feel free to ask them in the survey. So what I'm going to do is I'm going to set a timer. I'm going to ask you to complete this survey in about 3 minutes. It shouldn't take you longer than that. So I'm going to start the timer now. Again, the URL is here in the slide, but it's also in the text chat. Oh, hi, Jason. See that you got your camera working. Thank you. We'll have a time in a little bit to introduce ourselves, so appreciate that. Good. So everybody, hopefully you're done with the survey. I'm going to go ahead and bring that up. So we can look at our responses. So this is just like who's in the class. And I like to share with you kind of the collective of where this small group, I believe there's 12 of us are here, stands in terms of your prior knowledge and experience with a variety of technologies and progress in the course. So it looks like, most of you have completed session 1. Thank you. That's great. I'll also enable my camera. So Jason, you're not sitting there alone up there. So okay, good. So let's go ahead and look at, so session 2, looks like 8 of you have completed that. Great. And 1 person hasn't started yet, and that's totally fine. I just ask when you attend your next web meeting that you've completed both sessions 1 and 2 fully, and try to engage a little bit with session 3 and 4. It makes it much more valuable for you because it serves as a reinforcing review. But you'll figure out how you learn this content best and what works for you. I'm just giving you a suggested approach that has worked for many before. Which exercises have you completed? So it looks like 100 of you completed exercise 1.2. Awesome. So you know how to use R as a calculator. That's great. And a good chunk of you, good proportion of you have completed exercise 2.2. Wonderful. And I love looking at this pie chart. I don't think it's a well-designed pie chart. So if you read anything about my background, my area of expertise is data visualization. But this pie chart does tell us a little something about the class, like pretty clearly. So one, we could see that there's just 2 people that are new to coding. Great. This course doesn't assume any prior knowledge, so you're here at the right level. So some people have taken a couple coding classes before, about 6 of you, so about half in this group, and consider themselves definitely a novice. We have a few people that know enough to be dangerous. Watch out. And then we have 1 person that is very proficient at coding, intermediate, and these proportions really are match closely to what I saw yesterday. So I had a group of 22 students that attended last night's session, and R seems to be something that is or coding, not a skill that necessarily everybody has at a level of intermediate or advanced. So let's look at what your prior experience with R is. So more than half of you have reported that this is your first introduction to R, and again, that's like totally at the right level. Some meaning 3, 27.3% of you are somewhat familiar with R, but haven't actually used it, and then 18%, which really just represents 2 people here, are familiar with R, have used it a few times. No one's in the expert user or frequent user category, and that looks pretty similar to what I saw last night as well. So the idea of this course is to make sure that you're learning R from the ground up. But it's good to know also if you have any prior experience with specific languages. Excuse me. And so here's our bar chart that's not labeled very well, that tells us a few things. We could see some people have some experience in Python. If not, don't worry, you're taking Panos's class, and he has some great online modules to really help you develop a high level of proficiency in R. 1 person experience in Java, 2 in C, 1 in C++, 1 person PHP, 1 person JavaScript. And again, these could be duplicates, so 1 person can kind of just know all of this that have reported here. So we see some basic. So you can see that where we kind of stand as a class. That's great. And then I'll look to see if there's any questions right now. It doesn't look like anybody has any questions to start off with. I did get a few in the text chat, so I will try to answer those as we go along. So Anne, I'm just going to call you out and just say that I got your question, and we're going to try to address that today. Great. So thanks for your patience filling that out. I hope that's helpful to kind of see where you stand relative to your classmates, even though this is just a subset of them. So what I'm going to do now is I'm going to bring back up the PowerPoint. Okay. So that just takes me a moment. Okay, there we go. So I thought I'd share a little tiny bit about me. So as you probably know, I'm a associate professor here at Stern. I'm in the information systems group of what's called the IOMS department. So that's Information Operations Management and Statistics. Many of my colleagues that teach in this program are part of that department. And one of my areas that I focus on a lot of my work is in data visualization. And how does that lead me to coding? Well, so as an undergrad, I was actually at Stern in the same department that I'm teaching in now. I did take a little hiatus and I spent some time getting my doctorate at Columbia. But I started out as a tech person during the .com era, Web 1.0, and learned coding as right out of high school. And it's kind of been with me ever since and been using it as a tool to be able to analyze, manipulate, model, and present data in a variety of forms in my practice. And so my practice ranges from not only areas of business, but also it spills over a lot to education. And so one of my areas of and passions of research is known as learning science. And this is basically designing experiences and environments to help students learn from a more cognitive perspective. And it gets kind of complex, but the idea is that my field is focused on exactly what the learners are doing in a learning environment. And learners can be anybody from people that you're training in a business to K through 12 to kids. My focus has always been in higher education and also professional training of executives. And so I'm concerned about how learners are learning in an environment and what exactly they're doing to show evidence of their learning. And so that's kind of a fun area, and it's really become very contemporary in this with these new approaches to using analytics to learn a lot more about what your learners are doing and how they're doing it. So it fits really nicely with my field and a nice overlap with some of the work that I already do in business and visualization. So that's a tiny bit about me. I advise a lot of students on their capstone projects, which you probably have heard of already. So that's always a fun experience. So you usually work with a faculty and they advise you in that process, and you'll get a whole orientation on that. I also have another role is that besides a faculty member here, I run a group called the Learning Science Group at Stern. And what that group does is that we're part of this organization called the NYU Stern WR Berkeley Innovation Labs. And one of the roles of the labs is to kind of advance education, business school education. And so that's part of, so I'm the director of that group. And that lab also runs business plan competitions and startup challenges. So it's a really unique center. So I suggest that you stop by when you're at Stern. It's kind of a fun place to be. One other final thing about me, I have a book coming out that you'll read as part of the Data Viz course that you'll take with me in NYU Shanghai. So I'm very excited. It's going to come out in September, so just in time for the course. And I actually have had some former MSBA students actually contribute to the book and contribute data visualizations in their work. So that's been really exciting. And it's really focused on analytics and business cases and how you use visualization to explore and also to present data. So that's what this little banner is up here for. It's just kind of a reminder to myself to say, hey, check this out. And also want to let you know that feel free to connect with me on Twitter or LinkedIn. Check out my website. A lot of students are already connected with me in LinkedIn. Just want to let you know that that's totally fine, totally cool. Like, I encourage it. It's great to connect on other platforms, and I usually present some updates of some things I'm working on Twitter. And it's if you want to follow me, I also follow like a lot of major R blogs and R bloggers. And I tend to retweet and also provide some authentic tweets around things that like I've discovered with R or that might be helpful. So feel free to check that out. So my Twitter handle is @Sosulski. This is my website, and LinkedIn, you'll be able to find me pretty easy because I have a pretty unique name. So that's in a nutshell, a little bit about me. I have this slide up here, but just kind of showing my pathway in academia. So I started at Stern, I was at Columbia, and now I'm back at Stern as a faculty. So I also did spend some time teaching at Columbia as well. One of the first courses that I taught was actually computer programming. So I taught Java. That was the first course I ever taught before I kind of fell in love with teaching. And so I've been teaching coding, I think, since 2002 to graduate students and moved on to executives and folks like you as well. I'm introducing R to my undergraduate students today. So I hope to report back that they're taking to it as well. I also work with a lot of different businesses and bring a lot of different scenarios into the classroom based on real businesses and their needs. I do this for my data viz course and a few others, but this is just a preview of that. So again, I keep saying enough about me because I really want to hear about you. So what I'm going to do is this exercise is twofold. One is that we get to learn about each other, and then I get to make sure that your mic is working so you can talk. And feel free to use your camera if you have it. So I have an attendee list that I printed out from everybody that's registered, and I'm just going to call your name. The first person on my list is not here, so I'll go with Janky is the first person on my list. And so Janky, I'm going to say, hey, can you introduce yourself? Just take 15 seconds to tell us a little bit your name, your location, where you're kind of calling in from, and what you do. And so to do this, please just unmute your microphone, and then you can just freely speak. So Janky, we can't hear you, but just try introducing yourself. And if you're having problems, it's cool. You can just type a message in the text chat, and we can come back to you as well. Okay, so Janky, we're going to come back to you. I know that you're here, and I'm going to move on to Paulo. Paulo, are you here? And is your mic working?
Yes, can you hear me?
Yeah, we can. Welcome.
Thanks. I'm Paulo again, and I'm in Hong Kong. Actually, I'm working as a audit manager at the Hong Kong Stock Club. So basically, I'm the one driving how to utilize data analytics in performing internal audit.
Oh, wow. And what time is it in Hong Kong?
Well, it's 10 p.m. right now.
All right. Well, thanks for staying up for us. Great. Well, welcome. Next, we have Jason. So I see Jason's on the camera as well. Jason.
Hi, everyone. Hi, Kristen. Yes, I'm Jason Moss. I'm calling from Johannesburg, South Africa. And I run an operations team at a bank called Standard Bank. And essentially, I'm responsible for the processing of cross-border payments. Yeah.
Great, great. And what time is it in Johannesburg?
It's 4 in the afternoon, so I just grabbed a meeting room in the office.
Great. Well, welcome, welcome. Next, I have Prasanjit.
Hi, Kristen. Hi, everyone. Can
Hi,
you hear me?
welcome. Yes, we can.
Hey, thanks. So I am Prasanjit Mohanty from Bangalore, India. I am a senior project manager for the IT applications and also drive the reports for our group office.
Oh, great. And what's your company?
It's Amicorp.
Great. Welcome. Thank you. What time is it in
Yeah, thanks a
Bangalore?
lot. It's 30 minutes past 7 p.m.
7 p.m. Okay, all right. So I'm learning that this is a good time for non-New Yorkers. Yesterday, I had all New York and New Jersey people. It was interesting, but maybe you guys will prove me wrong. Okay, Santiago is next.
Hello, everyone.
Hello.
My name is Santiago Diaz. I currently live in Washington, D.C., and I'm a management consultant that focuses on business process improvement and strategy.
Great, great. Are you do you work for a firm or are you self-employed?
Yeah, I work for Accenture.
Accenture. Welcome. Great.
Yeah, thank you.
Next, we have Maria.
Hi, hello, Kristen. Hi, everybody. Can you
Welcome.
hear me?
Yes, we can. Welcome.
Hi, hello. I'm Mari Carmen Torres. I'm located in Peru, and I am the Senior Vice President of Retail Risk Management at Banco de Crédito del Perú. And also I'm a board member of Mi Banco, which is a microfinance entity here in my country.
Wow. Well, welcome. Welcome. I've always wanted to visit Peru.
Oh, you are more than welcome.
Okay. Great. Next, we have Chow. Oh, Chow, I don't know if you can hear me.
Hello.
Hi.
Hello, great. This is Chao. I'm currently in Shanghai, but I will move to Tokyo, Japan in a month, right before I fly over for our module one. I currently working for Mondelez, the food company who build biscuit, chocolate, gum, candy, blah, blah. I'm responsible for the biscuit category to evaluate the marketing performance in the region.
Wow. Well, welcome, Chow. What time is it in Shanghai?
10.
10 p.m., right?
10, yeah.
Exactly 12 hours ahead. Great. Well, welcome, Chow. Next, we have Anne.
Hi, I have to say it's so much fun to hear everybody's voices. I'm Ann Michael, and I am located right outside of Philadelphia in the US in Pennsylvania. And I am the CEO of a small consulting firm that I started in 2005 with about a dozen of us, working mostly in scholarly and academic research and information. So with like the New England Journal of Medicine, Nature, Science, and we do a lot of work on digital transformation, and we've become very data focused. So that's why I'm here.
Oh, great. Welcome. Welcome, Anne. Next, we have Jason. Jason Iszer.
Hi, everyone.
Hi.
Hi, everyone. Yes, Jason Enzer. I'm actually a chief technology officer at a boutique asset management firm in New York City. I'm currently calling in from Connecticut, and I've spent 20 years in the financial services industry, including around 10 years in Tokyo, Japan.
Wow. Wow. Well, welcome, Jason. Thank you. Next, we have Martin. I don't see Martin, so we'll skip ahead. Michael.
Hi, everyone. Can everyone hear me?
We can. Welcome, Michael.
Hello. My name is Michael Cavallaro. I live in Jersey City, New Jersey. I work at DTC, a financial services company in HR analytics as a senior analyst. My passions drove me to pursue further education in analytics. I recently made it through a data science boot camp, and I'm here in the MSBA program.
Well, Michael, wonderful. I'm curious if you know Sam Feldman. She's part of an HR analytics consulting firm. She wrote a little piece for my book, and she's an MSBA grad. All right. Well, we'll catch up later on that. Next, Benson.
Hi everyone, I'm Benson from Singapore. It's 10 at night here, also 12 hours from you guys in New York. I am a civil servant at the government of Singapore, working with the Prime Minister's office, and my focus is on national security.
Well, wonderful. Welcome, Benson.
Thank you.
I'm going to return back to Jenki. I don't know if you're available, but if you wanted to just, if your mic's working, wanted to say hi.
Hello, everyone. Am I audible?
Yes, you are. Welcome.
Hi, I'm Janki from India, and I'm working with wholesale merchant and basically into retail analytics.
Wonderful, wonderful. Well, welcome, Janki. Did I miss anyone? Might have signed up after I printed out my sheet. Okay, well, if I did, please feel free to send me a chat in the text chat, and we'll make sure you get a chance to introduce yourself. But I don't think I see anyone. Well, thank you. Isn't this impressive? Just hearing where everyone is from. This is such a diverse group in terms of just like the global distribution of the 11 or 12 people here. It's pretty amazing, and all the interest and passion for analytics and data analytics and the roles that you have now, just very super impressive. One of the things I love about this program is I get to be one of the first people that you meet, even if it's in a web format, just to be here to welcome you and kind of build on the energy and enthusiasm for this program. And it's really the people that have been selected from a highly selective process to kind of be part of and form this cohort of 60 or so students for the MSBA program. I've been teaching in this program ever since it began in 2013. So the first course I taught was data visualization in Shanghai. And believe it or not, we didn't even have a campus at the time. So we actually went there as kind of like our pilot first class and taught one of the first modules. It was actually module 3 in Shanghai. And that was really exciting, and things have just progressed and gotten so much more sophisticated. And the area of analytics, the examples and the cases and the practices have really changed in just a few years. So it's been a very rewarding program to kind of teach and engage in. So thank you for taking the time to introduce yourselves. Obviously, we're not going to do this every time we're on a GoToMeeting. I just like to do it for the first time, just so you kind of have a sense of like where you kind of sit, and in terms of like your knowledge and skills compared to your peers, but also like who you're sitting with. And I think that's pretty cool. So what I have up here this is something that was embedded in the syllabus and also in the introductory materials, but this is a suggested roadmap. And I say suggested because all the work that for the pre-module is due at the end of the pre-module. However, I suggest that you get it done earlier, and many of you are on your way. You've already completed, the exercises 1.2 and 2.2, so you're progressing well. And I just suggest that by mid-April that you have the R part of this course complete. Then you can really jump in and focus on the statistics part of the course, which my esteemed colleague Peter Lochner is teaching. So I just teach you the R foundations, and he really focuses on the statistics. And that allows for a nice separation where you can kind of learn coding first and get the foundations, and then use it to analyze data in a more sophisticated way. So feel free to, ask me questions about this. But the idea is that before you come to a live meeting, try to have completed the lectures, sign up for a web meeting, attend it, and then do the homework. Now, the first couple lessons, it seems like all of you have breezed through, so I'm not worried. But if you do have questions before you complete your homework, you come to the live meeting and you can ask them as well. And we grade on a rolling basis, and so every about twice a week we'll go through. We'll see who submitted assignments, whether it's from chapters 1 through 6, and you'll get feedback within that week. So that's kind of like the promise that we try to keep for you, just so you get your feedback pretty rapid. So how are we going to work today? Well, I'm going to ask you to open up RStudio. And that, of course, requires that you already have R installed and that you have RStudio installed. And while you have that open, I'm going to be delivering a small mini lecture on some basics that have to do with R. And then I'm going to ask that you have available exercises 1.1 and 1.2. I'm sorry, and 2.1. If you have no idea what I'm talking about, there's a materials tab here, and you can click on the links, and that will link directly to the exercises. If you're very familiar with what I'm talking about, thank you. All these materials are available in that online book that I put together for you. All right, so because we're kind of dealing with working together simultaneously in RStudio, and then I'm asking you to look at some exercises, and then I'm asking you to use GoToTraining. This is just a suggested way for you to kind of set up your screen. So have one part of your screen, maybe a third dedicated to RStudio, bring up an exercise when I ask you to. You don't need to do that for a little bit. And then also have your GoToMeeting window open so you can type some responses in the text chat. All right. And at this point, I'm going to turn off my camera because you probably don't need to see me. And I'm just going to move on to the next slide. And so this is the part where I'm doing the mini lecture. So here is our RStudio environment. And I just want to take the time to explain each of the different quadrants. And so we have this quadrant here, and we can call this quadrant 1 if you want. And this is what's called your environment. And this is where you have the ability to click here and import data. Okay, you have the ability to look at the different data sets that you might have imported that are available for you to work with, that are essentially objects. So I have one called movies, another one called sidewalk. And then I also have things called values, and these are variables that I've created. So I've created a variable called age, I've created another one called area. And these are just, this is just here, so I can reference that really easy, and I know how I spelled the variables and all of that. Going down, you'll see here I have a simple scatter plot that shows a perfect linear relationship here with a regression line. This is where if you're building visualizations, they will show up. It's one place where they can show up. It also is a place where if you click on the packages tab here, you can install packages that you might need to use. And packages are just basically a collection of functions. And functions are what I call the verbs of programming. Functions allow you to manipulate objects or data, okay? So if I want to round a number, I would probably use a function called what? What do you think I would use? If I wanted to round a number. So my number is 3.147, and I want to round it to two decimal places. If I wanted to do that, I could use a function called round. And I can pass in my data. I'll just write it out in the text chat. So I could say round, and I said, what did I say? 3.147, comma 2. This is an example of a function. I'm sorry, I just set that directly to Anne. I need to send that to everybody. Okay, and so I'm passing in some data in my function, which is 3.147, and then I'm another parameter that's separated by a comma is the number 2. What do you think that stands for? If you have an answer, you can just put it in the text chat. The number of decimal places to round. Totally. Great. So packages, again, are a collection of functions. And some packages have been preloaded in what's called base R. I tend to write a few notes in the text chat, but base R. What's pre-installed with your version of R. And then there are other packages like a package called readr. That's a name of a package, and that's a package that you'll use to import your data, okay, that you need to have installed. And we'll get to all of that. So you'll always know when you need to kind of install packages, but this just extends what's called your base R. If you want to graph stuff, you're going to want to use something called ggplot. That's the name of that package. If you're going to do a network analysis, there are packages for that. If you're going to do geospatial visualization, there are packages that allow you to do that. So the great thing about R is that the packages are pretty encompassing, and so you tend to learn like a package at a time, and your package can be thought of as your toolkit. And I like to, again, think of them as a collection of functions, or really the verbs, okay, the workers of your coding environment. So Jason, great question. You said you saw something about using tidyverse. It has a bunch of packages built in. Yes, we're totally using tidyverse as part of this. So tidyverse is a collection of packages. So now you can have packages within packages. And it also has that readr library also as part of that. So it's going to be, that's a package that we're going to use. And tidyverse is something that was developed by Hadley Wickham. And he is a person at RStudio that does a lot of work and development and contributions to R and the R ecosystem. And it's put together this package that allows for what he calls tidy data. That's why it's called tidy. I'll just write this out in the text chat so you can see what I mean. Tidy data, the philosophy behind it, I'm really glad you brought this up, Jason. The philosophy behind it is that variables are stored in columns and observations are stored in rows. And every column can be thought of as a vector with the same data type. So you have a column named age, let's say, and it has they're all integers, okay, for age. Or it's date of birth, and they're all of type date, okay? And we'll learn a little bit more about data types today to specifically describe how we categorize our data, which is very important. But tidy data is very important. We can have data in many different formats. We can have it in a matrix. We can have it in a wide format or in a long format. What tidy data emphasizes is having data in what's called a long format. And we'll get to talking more about that. But I hope that satisfies your kind of inquiry, Jason. And please feel free, if you just want to speak up instead of, texting in the text chat, that's totally fine too. Okay, so thanks, Jason. Okay, I'm gonna move on to talking about this quadrant up here where you see, source on save, and you see some text that I have written, and this is where you're gonna write all of your code once we get to chapter 3, where we're talking about writing scripts and writing programs that we can execute. That's going to all happen up here in this space. You're going to create what's called notebooks and markdown files, and all these terms you'll become very fluent in. And I'm going to be a little bit annoying about using the terms in which things are called. So if something is a variable, I'm going to call it a variable. If something is a method and it takes a set of parameters, I'm going to use the language of programming. So you're familiar with what things are called. in addition to the syntax. So a syntax might be, how do you create a variable? So a syntax might be that you have to kind of say like, I'll write it in the text chat. So I'm assigning the value of 0 to x, and that's a syntax for what we call variable assignment. But I'm going to try my best to make sure that I explain what all these things mean, so you're clear. But if you have questions along the way, please feel free. But try to use what I call the language of programming as you describe things. It helps with just how your comprehension of what's going on, what the different functions are doing, and how they're manipulating or altering data, for instance. So here's where you're writing your scripts, like I said, and then down here, what I call the console, this is where you're going to be using R as a calculator. So this is what you've probably done for exercises 1.2 and 2.2. And this is where you simply just type at what's called the command prompt. Okay, it looks like a greater than sign. And then you just type, you could say 2 + 2 and press enter, and you'll see input and output. Okay, we will be using this. This is a great place to write like one line of code. When we have to write more than one line of code and we might want to edit it, that's why we create scripts, or it's almost like having a document that has all your code, and then you choose when you want to execute it. Okay. So let's look at this idea of input and output, and imagine we're in the console window. So we type something, and you can feel free to follow along. 3 + 2, but that's our input. And again, this greater than sign, that's just representing the command prompt. Okay, and then what's our output here? Our output is 5. Okay, and then again, here's our input. We have an input here of 100 divided by 5, and our output is 20. Here we have an input of 12 + 12 + 12, and our output is 36. Does anybody know what this 1 in brackets means? It's the first line, not necessarily the first element. So if I had an output with 5 or 6 different values, it would still say output 1 in brackets. Okay, and that's just what's shown in R as the output. It shows me the line. Okay, we only have one line of output because we don't have very complicated data that we're working with yet. Okay, and we're not doing anything very complicated to it either. Good. So, and in this example, I've showed you some examples of arithmetic operators. These may seem pretty straightforward, but I like to go over them for a specific point that speaks to the type of data that we're working with. So when we use the plus operator, obviously this is for addition. We can also use the plus operator to do something else called concatenation. We're not going to spend too much time talking about that now, but concatenation is where you can, string together like characters, okay, and form words or something like that. We use the plus operator as an arithmetic operator to add two numbers together. So we're dealing here with numeric data. So we can't necessarily work with, say, Boolean data or other data that's non-numeric and use the arithmetic operator. I know that seems pretty logical, and calculators don't let you put other information in that's not numeric, but R does, right? R lets us put in letters and words and many different things, functions. And so we want to make sure that we use the operators that work on this data that we have. Subtraction is the same thing, division, multiplication. So those of you new to coding, for multiplication, we use the asterisk and we don't use the X, okay? If you want to use exponents, raise some value to the second power, let's say, we just use the caret, which is on top of the 6 key. And if we're doing some kind of fancy, integer division, we can use modulus, which returns the remainder from integer division. and that's just a double % sign. I like to introduce that just to kind of show some of the breadth of the arithmetic operators. Now, a lot of times we're not going to be working with R as a calculator. So we're going to want to store values, like the value 3, and variables. And variables is just a reference. It doesn't contain the value. It's just a reference to the value. Variables are great, right? Because we can update variables. And that's just part of the what a variable actually means, right? Part of the definition there. So what's happening here? So we're going to read this from right to left. We're assigning the value of 3 to the variable named x. And we do that using an assignment operator, which is this less than and minus sign. It's a little odd. So anybody who's coded before, what have you used for assignment in the past? Yeah, Jason, right? You're using the equal sign. Can we use the equal sign for assignment in R? Yes. Should we? That's some people say yes. There's arguments for and against it, and I'm going to give you an argument against using the equal sign for assignment, and we'll get to it. But let me explain for everybody here what's happening. So again, we have the name of our variable, we have an assignment operator, and then we have the particular value we want to store or reference in that variable. Okay, so if you type this in R right now, you would have a variable named x that could reference the value 3. Fine. So we can use the equal sign. Okay, so everyone's right by saying we can. Should we? Matter of opinion, and I'll go on to explain why. But here we have our name of our variable, we have an assignment operator, and then we have the value that the variable is referencing. Fine. So here I like to make a few points. First is, if you ever want to look at any documentation besides your own code, R coders use the R assignment operator. So it's kind of these things like, well, if you're going to code in R, you might as well do it in the way that the community is coding in. All the examples and documentation use this operator. And so just to kind of keep your sanity, I would suggest using the previous assignment operator that I showed. So that's definitely one of the reasons. The other reason is that if you're new to coding and you're new to R, it's nice to really separate out this notion of equality from assignment. And by having a different operator, it's helpful to do that. So what's equality? Well, equality is where we're looking to see if two values are equal. And we're interrogating our data. So I might say, you know, this statement that I'm writing here, x double equals 3. What does that mean? Yeah, so Paulo, you're getting it. Yeah, you're getting what I want. Like it's about the question, right? Or Jason, right? It's a test. So I'm asking the question. I'm going to write it here again. Does x equal 3? Okay, and x might have a value, and so here I'm testing for equality. Okay, is the value referenced in x equal to the actual number 3? And what's going to be the answer to this? So Boolean, a true or false, right? And we've assigned 3 to our variable x, and so we're saying essentially, does 3 equal 3? And it's going to return a true. Okay, and that's just to note the difference between, again, assignment and equality. And we test for truth for many reasons. We need to interrogate our data. We want to know if it meets a certain condition. And to do that, we tend to test for what we call truth in programming. So take a minute, assign a value of 42 to a variable named y. Go ahead and do that. Once you've done it, you can cut and paste your code in the text chat just to kind of share it with me. Thank you, Paulo. Great. Good. Right. So you should have done something like this. Wonderful. And if you want to see what value is referenced in that variable, you can simply just type y at the command prompt. So you can go ahead and do that, and you should see 42. Okay, that's how you access that variable. And now, guess what? We can do stuff with this variable, right? With y, we can add 2 to it. So in this first line, we're adding 2 to the variable y, and we get return the output. The computation gets returned. At this point, what's the value of y after I've added 2 to it? It's still 42 because I haven't necessarily updated the variable, okay? I've just done a computation with it like a calculator, but nothing saved. Okay, if I want to square y, I can just use the exponent function here, and you can do that, again, using another arithmetic operator. If you want to update a variable, so again, we've assigned 42 to y, and let's say we want to subtract 1 from it. So we can say y minus 1, so we read it from right, and then we look at where it's assigned. It's assigned here. So now y is 41. So I like to also show this example because you see the assignment operator, which is a minus sign, and then here, and then you're just subtracting 1 from y. All right. Please let me know if you have any questions. So this next example is we're assigning the value 42 to y, and now we're assigning y to x. So this is called variable reassignment. And this is also very helpful. So we can not only reassign, single values to one another, but whole vectors or whole columns or whole data sets we can reassign and essentially change the names and the references. So this whole exercise is really around getting you familiar with the variable assignments, but also data types. And in R, anything that's a number, okay, anything that you can do math on is going to be part of what's called a numeric class or a numeric data type. These include integers, okay, numbers, whole positive or negative numbers are integers. Floats are known as floating point decimals, so anything with a decimal after it. Or what we call an integer or an integer vector as an example. A vector is a certain type of data structure. So we've already learned about a variable. And a vector is simply think of Excel. Think of just one column in Excel. So there are totally float vectors, Santiago. There are Boolean vectors. There are character vectors, vectors of any type, okay? So a vector is a data structure that can have a data type. It can be of type numeric. In this case, it would be, but it contains integers. Good. And I'll explain what we're doing here is we're actually just creating a vector, okay, that has a set of values. We'll practice doing that. There are other types of data structures besides numeric data. So numeric data we can do math on. We have to use functions that accept or take parameters that are numeric. Okay, and sometimes we need words, all right? Or if we're going to change everything to uppercase, I can't do that with an integer. Okay, I need a word to do that, right? I need a character, which is a certain data type. And I can also have character vectors. All right, let's do a code walkthrough. So we've created that variable called x a while back. And if I use this class function, it's going to tell me the data type of that variable, which is going to be very handy. So I know that x is a numeric variable. That's helpful. If I assign a floating point number to z, and I look at the class of z, the data type, I can see it's numeric. Okay. If I assign the word book to b, and notice when I use characters, they need to be in double quotes in my input. All characters need to be in double quotes. I assign that to B. If I type the letter B, I get the output book. And again, if I want to see the class or the data type of the variable B, I just say class and I pass in the name of my variable and it returns the data type. So any questions on that? All right. I mentioned vectors before. So it's just basically a whole collection of numbers that are stored in one variable. Now, again, imagine a vector is just a column in Excel, a column of data, right? And it's all of the same type. So if you have a column that's like date of birth, it's going to be all the same type of data, or a column with age, or a column with eye color. It's going to be, while the values may vary, blue, green, hazel, brown, the type of data that's stored should be similar, all characters, for instance, unless there's missing data, and then that's another problem. See chapter 6. Okay, so here we go. We're going to create a vector. So we use a function called C. This is confusing because it's just C. It's not very descriptive, but C means combined, combine. And it basically allows you to combine a set of values, a set of elements, so 1, 2, 3, 4, 5, 6 elements together in a vector and store that in a variable. So that's pretty cool. And then now X has been reassigned this vector of 6 numbers, and I can operate on an entire vector. So I can add 2 to the entire vector. So X plus 2 is adding 2 plus 1 and returning 3, 2 plus 2 returning 4, 2 plus 3 and returning 5, and so on. So Jason, you're asking about C is for vectors, but there's an issue using cbind. Cbind is actually for combining data of the same type into a matrix. So cbind is a function for creating matrices. If you want to combine 2 vectors together to create a matrix. The key with cbind is that the data structure that it forms, Jason, is all values have to be of the same type. So let's say I have characters and I have numbers. It will change those numbers to a data type of character. So that's just a note on cbind. So Jason, let me know if that satisfies your answer. Okay. So the next simple exercise is to create a vector. So now I want you to create a vector and I want you to name it months. And I want you to have the integers 1 through 12 in that vector. So I need 12 values there. And then I want you to square that vector. So go ahead and do that and type your response in the text chat. I'll give you like 30 seconds. See how you do. Okay, these responses look good. Thank you. And you notice that there's a couple ways that, so if we look at Chow's response and Anne's response, they're different, but they're both right. So there are a few ways, again, to solve a problem in R. So let's look at my screen now. So the first one, let's look at the first line of code. I'm using the combine function and I'm passing in numbers 1 through 12, and each element doesn't have a quote around it, meaning that it's a numeric and it's separated by a comma. Then I assign that to a variable called months. An alternative, notice I put a little pound sign here. This just means a comment. I just wanted to write something in English that just, what's an abbreviation in English? It's hardly English. That just meant this is an alternative solution. And here I'd say numbers 1 through 12. Okay, and that is going to do this. That's going to create a vector, the shortcut. Okay, and I'm using the colon to say 1 through 12, inclusive of the number 1, inclusive of the number 12, and assign that to months. And then I can square that vector. Yeah, Chow did type less, so you'll find that your typing is takes more time, right? So now you're going to ask you to, everybody has to do some typing here, unless somebody finds a more eloquent solution. But create a vector called days with the days Monday through Wednesday. Policy will mostly be necessary when you want to create vectors. Great, Jason. Looks good. You have the double quotes around the names of the week, which is important. Michael, also very good. And then you can go ahead and use the class function just to make sure that it's returning data of type character. Good. So I see Jason use the equal sign. That's cool. Good. Class characters. Okay, code looks good. Code looks good. And then so Santiago, let's say if you wanted to make all your vector uppercase, you can use a function to make everything uppercase. For instance, notice that you put everything in lowercase. So there's functions that allow us to manipulate text data as well. All right, so I would say Janky, let's just use, for assignment, to keep things simple, let's just use this operator, not the double. As we move on to using more and more functions, I just wanted to give you, a kind of definition around this. So we're operating on some specific argument. Those arguments I tend to call parameters in a function. So whatever's within the parentheses, we call those parameters. Right, and I did say you could use that as well because it works. So you can certainly use the assignment operator in any direction you wish. Traditionally in coding, when you're just talking about variables and assigning, it's the left-hand sign that has the variable, and it's the right-hand sign that has the values, whatever it is, the vector, the data frame, the value being assigned to. But you can do it both ways. Totally. So Santiago, you don't need to use the C, but you can. You could write it out literally as well. So some functions we have are built in. So we have the square root function. Obviously, that will take the square root of any value. So it's different than using operators, which we used before, like in a multiplication operator or an exponent operator. Here we're using a function called square root, returning the value of 5. We have a function called mean. So let's look at this one together. So first, I'm using this combine function to create a vector. 1, 2, 3, 4, 5. 5 values. And then you notice another set of parens. I'm passing in my combine function into another function called mean. So it's a function within a function. So this is where, while it looks pretty straightforward and simple, things can get complex pretty quickly if you do functions within functions. Because I know that the C function produces a vector, and then I can take a mean of a vector, okay? Especially when I know that vector is all of the same data type. And of course, I get the value of 3 for the mean of this. I think I was talking to Santiago maybe, but if you wanted to convert, let's say, your data to uppercase, you can just pass in your data, whether it's the raw data or a variable, and it will convert it to uppercase using that type of function. And there's thousands of functions that you can use. You just need to know what kind of data you need to work with in order to manipulate it. Good. So we're going to start working on practice exercise 1. So there's a material tab materials tab in your go to training, and just you can click on exercise 1. And the objective here is to just like get some more practice and write some of your own calculations. So what I like to do is just tell you to go to our fundamentals, our website, or click on exercise 1.1 under materials, and you'll get the exercise here. It's pretty short, so I'm going to ask you to get started on the first 4 questions. And when you've done them, you can just type your response in the text chat. I'm going to go through it as well. I'm going to take a minute, bring up my RStudio, but since you already have all that stuff up, I'm going to ask you to just go through questions 1 through 4, and then we'll go through it together. When you're done, post your answers in the text chat. Okay, if you're watching me, that's fine. So I'm just setting up my environment here. I have a lot of stuff already in my console window. I like to clear it by saying Control L. That clears my console window, so I can start with kind of a nice white space. I'm going to open up my chat so I can see if you're writing anything. Great, so I'm seeing responses already. And I'm doing these at the same time. So one is about following the order of operations and making sure that you use the right operators. So you should be getting a value of 130.5769 for the first question. If you've done that, you can take exactly what we've done and you can round it using the round function. So pass in your computation and then round it to 2 decimal places, just to kind of practice using functions in the output. The next line is about computing the absolute value of -88. And of course, that's going to be 88, but we use a function for absolute value. And when you're working with the March Madness data set that I give you, I'm going to ask you a question that's going to require you to use the absolute value. And I'm going to ask you about how many places a team has changed in rank from the previous year to this year. To do that, you need to use absolute value. Next, I'm going to ask you in question 3, to take the base 10 logarithm of 72. Okay, and there you should get a value of 1.857332. So you don't know what log 10 means, right? You just see this function, but you're like, what does this do? Question mark log 10, press enter, and in the right-hand side, you'll see a help file that will describe what this function does and then how to use it. You could always even do something and check the log function of 72, and you should get approximately 72. Good, good. Okay, and then we're going to use the exponential function and just to subtract a value from it. You should be getting 1.65, good. And if you want to nerd out, you can write your own. We're using Euler's number here. Great, thank you for all your responses to this. This is great. So if you're done with that, we can move on to our simple age computation. And I just want to kind of walk through this with you. So you have year born. So I'm going to clear my screen. And we want to see if you're old enough to vote in the US. That's question 5. So to work on this, we can create a variable called year born, assign it the year of 1984, a variable called year current, assign it a value of 2014. Notice that I'm using the underscore for my variable names. You don't want to use spaces. Okay, no spaces, no special characters. Okay, just keep it simple, all lowercase for variable names and make them descriptive. And then I'm subtracting year current from year born, and then I'm storing that in a variable called age. And then I'm evaluating to see if age is greater than or equal to 18. And it's returning true. Even though I know it is, if that variable changes, my code still works. Good, Chow, thank you. Okay, a few more things. So we're going to compute the radius based on the information given and knowing the how to compute the radius. So we'll start here. So our area, we're setting our area equal to 100. And then we're taking, of course, the square root of area divided by pi. So pi is a variable that's a variable in base R that you can always access. You don't actually have to create it. Okay, so anytime you need to use pi, you can. It's kind of built in for you. And so there I can get, and then R, of course, is my radius. I like, Paolo, what you did, but I wish you didn't say 100 divided by pi. I wish you used a variable for that. But it's right. Good, 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 good. And then we have our simple tip calculator. You'll do one of these in Python as well. But this is just kind of a fun exercise. So you went to lunch and the bill was $45.90, and I want you to calculate the subtotal and the tax and look at a 15% tip and a 20% tip. Oh, Benson, you asked a good question. When do you use the print function? You know, I show print. So if I said something like print X, I don't have an object X. Let's see if I say print B. So if I print B, which is book, if you remember I created that a while ago, it's the same thing as typing B. I like to show print for 2 reasons. One is that in Python and how you're going to be working in your IPython notebooks, it keeps the formatting really nice, and it's how Panos teaches the output in Python. So just knowing that print exists kind of across programming languages. The second reason that you use print is if you want to do any formatting. So say if I want to print something and it's a variety of a couple of variables, okay, I can print them together. Not like that though. I might have to do concatenation there. But you can do some formatting with the print function. And then if you wanted to learn how to do that, you can just say kind of question mark print. You could decide if you want to like justify the text, for instance. But these are all the different parameters. Not really that interesting in the print function. All right, so let's go to our computing our subtotal for our bill with tax. So our bill, we're assigning the value of 45.90 to bill. Our tax rate we know is 8.875. And then I'm going to compute a variable called subtotal, which I'm just doing, tax rate divided by 100 plus 1, multiply that times the bill, and I get my nice subtotal. I can print out subtotal. I can round it. So I have 49.97 should be my subtotal. And then I can compute my 15. Once I have that, now I can compute my 15% tip. So, and you can round that. So you should have 57.47. If you wanted to compute your 20% tip, it should be 59.97. I'll wait for a few people to post their solutions. Yeah, Santiago, it looks like a little bit. Yeah, Paulo, you rounded to an integer, right? Because you passed in 0, so 0 decimal places. Good. I mean, maybe not good for the waiter or waitress, but. Okay, so the last thing that I want to go over today speaks to a question that came from Anne. But it's about how we work and how we import data. And you're going to learn how to do this in exercise, in the third session or chapter 3. But I want to just go through an example that's based on exercise 2.1. And I like to have this exercise included because it gets you thinking about importing your data. Now, there's 2 ways that you can do this. First is you need to make sure you've downloaded your winterolympic.csv file. It needs to be a CSV file. It needs to just be downloaded as a CSV file. You don't want to convert it to Excel at this point. Okay, so there's no reason to convert it to Excel. We should always keep the data in its native form for for purposes of like the exercises, because then you can start like kind of corrupting it, and then it can be kind of difficult to kind of get back to just working with the objective of manipulating the data. So first off, we want to make sure we download that CSV file. Again, this is all available in the R Fundamentals website for exercise 2.1. So once you have that, we have two ways that we can import our data. Need to make sure that we have our data stored in our working directory or available to us. So the first way that you have to know where that data lives, winter_Olympics. And if you're not following along, please just like tell me in the text chat. I can restart. But here you want to go to a place called Import Dataset, and you want to choose from text read R. Okay, if you have that option available to you. If you click this, you see that it brings up a window. Now it's asking me to browse to basically my hard drive to find, my winter_Olympics.csv. You see that I have that here, and I can go ahead and I can open that. Couple things happen. First, it tells me where my information lives, right? Because that's where I browse to. And it gives me a data preview. And it gives me a data preview with a lot of information, the column names and the data type for those columns. It's pretty cool. I can actually change that data type. So if I decide rank is not an integer, I can make it a double, or I can make it a numeric, which is more of that general class that I spoke about. I could skip including this column altogether. I'm going to keep it as integer. NOC means name of country, so that is a character. That makes sense. I don't think it's going to fit any of the other ones, right? Gold, that's the number of gold medals. That's going to be an integer, silver, etc. And region looks to be like a character. I could change that to a factor, which we're going to talk about next week. But right now, let's just keep it as a region, as a character. I can change here the name. And here you can call the name, you can call this data, or you can call it winter. I'm just going to call it data just so I don't have to say winter the whole time, but like you should really name your data something more descriptive. I'm just going to call it data for now for teaching purposes. And I'm going to make it lowercase. And then I'm going to keep everything else the same. But first row as names basically means my first row of data in my CSV file are the column names or the variable names. Want to keep those, okay? Everything else by default is going to be fine. And then you'll see over here a code preview. This is the code. You could actually write this code instead of going through what we've just done here, okay? But it gives you the code preview. And then you say import. And notice how my screen changes. Lots of things just happened. First, it printed out the code that it generated. It's using a library called readr that's required. That allows me to use this tool, and the tool is this function called read_CSV, and it's passing in this winter_Olympic.csv, and it's assigning it to a variable called data, and then I'm using a function called view to view the data in my RStudio environment. So that's just a simple thing about how we can view our data. But now we get to use all functions like summary functions to learn much more about our data, like the mean for each column. This is where I'm going to leave you for ending this session today, but encourage you to do exercise 2.1 on your own and try to work with this data now that you know how to import it. And then I'm going to just open it up to questions right now. So Jason, you might have gotten that because of how you might have downloaded the data. So I would maybe just go ahead and go back to where you found the data and click on the link, right click on the link and just download rather than open and download. It could have gotten encoded differently. If not, email me directly and I'll send you the data, and then you'll have one that wasn't kind of opened. Any other questions? I'll stay online for a few minutes. Santiago, thank you. Appreciate that. Maria, oh, there's going to be so many packages. It's a good question. There's many others. You'll be using one called, Tidyverse. You'll be using one called ggplot2, and it just keeps going. They'll be introduced in the online chapters. It's not like you can just have everything installed. This is part of coding in R's, that you're constantly installing packages. Thanks, Jason. You're welcome, Jason. It does make it real, right? Thanks, Anne. Okay, bye, Janky. Bye, Paulo. Bye, Mike. Bye, Benson. Everyone's welcome to Peru. Okay, excited. Bye, ciao.